There's a proximity sensor that can detect plastic, and wood, and glass, and liquid, and powder. It can even sense the level inside a tank through the wall without ever touching what is inside. An inductive proximity sensor cannot do any of that. It only sees metal. So what is this sensor that detects almost anything? It is a capacitive sensor. In this video, I will explain what a capacitive sensor actually is, how it senses a target by watching its own capacitance change, the one killer difference that sets it apart from inductive, how the sensitivity adjustment lets you detect level through a wall, and how you wire it into a PLC. Let's start with what is really happening at the tip. Quick note before we dig in. This is from PLC Simulator, where you can practice sensors and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now, back to the sensor. So what is a capacitive sensor? At the face of the sensor is a sensing electrode. Think of it as one plate of a capacitor. The target you're trying to detect becomes the other plate. When nothing is near, the capacitance between them is tiny. But as a target approaches the face, that capacitance rises. Inside, an oscillator is watching that capacitance. As the target gets close enough, the capacitance crosses a set threshold, the oscillator changes, and the output switches on. Move the target away, capacitance drops back, and the output switches off. That is the whole principle. It does not care what the target is made of. It only cares that something is changing the electric field at the face. And that is exactly why it is so flexible. Here is the one difference that matters most. An inductive proximity sensor, the most common kind on the floor, works by generating a magnetic field and detecting eddy currents in metal, which means it only detects metal. Wave a plastic part in front of an inductive sensor and nothing happens. A capacitive sensor is different. Because it senses a change in the electric field, it detects metals and nonmetals. Plastic, wood, cardboard, glass, water, oil, grain, plastic pellets, powder, all of it. That is the entire reason capacitive sensors exist. If your target is not metal, an inductive sensor is blind to it, and a capacitive sensor is the answer. I have separate videos on inductive proximity sensors and on the NPN versus PNP wiring. Both are linked below. So here we stay on what makes capacitive special. Now, the practical reality. Capacitive sensors usually have a sensitivity adjustment, a small potentiometer on the back. It sets how close or how dense a target has to be before the sensor triggers. Turn it down, and it only sees solid objects right at the face. Turn it up, and it gets sensitive enough to detect the level of liquid or powder through a thin non-metallic tank wall. No hole, no probe inside. But that flexibility has a price. Capacitive sensors have a shorter sensing range than inductive, usually only a few millimeters up to a couple of centimeters. And because they react to anything that changes the field, they are affected by humidity, dust, and buildup on the face. Set the sensitivity too high, and the sensor can false trigger on moisture or a film of dust. So you tune it, high enough to see the target, low enough to ignore the environment. Wiring it to a PLC is the easy part, and it is identical to the other proximity sensors. A capacitive sensor is a 3-wire DC device. Brown to plus 24 volts, blue to 0 volts, and black is the signal that goes to a discrete input on the PLC. And just like inductive sensors, it comes in 2 flavors. NPN, which syncs the output to 0 volts, and PNP, which sources the output to plus 24 volts. You match that to how your PLC input card is wired, syncing or sourcing. The full breakdown is in the NPN versus PNP video linked below. The PLC just sees a clean on or off on that input. Nothing special. So where do you actually use one? The classic job is non-contact level detection. Mount a capacitive sensor on the outside of a plastic or glass tank and turn up the sensitivity. It tells you when the liquid or powder inside reaches that height. Through the wall, with nothing touching the product. That is huge for food, chemicals, and hygienic processes. The other big one is detecting non-metallic parts on a line. A plastic bottle, a cardboard box, a wooden pallet, a bag of product. things an inductive sensor would stare straight through. If the target is not metal, or you need to sense through a barrier, capacitive is the tool. So here's what to walk away with. A capacitive sensor detects a change in capacitance as a target nears its electrode. And that one idea, sensing the electric field instead of a magnetic field, is why it detects metals and nonmetals alike. An inductive sensor only sees metal. It has a sensitivity adjustment, so it can read level right through a tank wall. Its limits are shorter range and sensitivity to dust and humidity. And it wires to a PLC as a simple NPN or PNP 3-wire input, just like any other proximity sensor. Get that? And choosing between capacitive and inductive stops being a guess. Now go make it concrete. If you want to practice sensors hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.